All right, line 3, learning task 1. It shows up as being like the third one inside of this section of your binder, which is why I got a 3 off of this one, but it's actually the L3 learning task that we are getting into, which is going to be detection systems. We're going to talk about ground fault detection systems over here at this point. We've gone over this one a number of times that we need to go and have ground fault detection systems. And in our previous learning test that we were just at, learning task L1, line L1, learning task 2, we took a look at the requirements for an ungrounded system. And one of those requirements is that they're to be electrically alarmed for ground faults and maintained by a qualified person. The alarm tells us when we've got a single ground on the system before it can migrate over to other lines and cause a dead short. And then that qualified person tracks down that actual fault that we are going to go and have on there. And you can do that through that pulse testing that we looked at before as well. The simplest type of alarm system is going to be the lights that we have seen before numerous times throughout here. We're going to go through them for the last time. At this point, once we see them from this point forward, we're just going to kind of skip over them because we've gone over them a number of times. But they look like this, and this one is a little bit different than other ones that you've looked at because we've also got the addition of a test button that is going to be tied to this thing. What we see right now is that we have got 3 lines that are going to be connected over here. We're going to have our A line, we're going to go and have our B line, and we are going to go and have our C line that are going to be connected like that. And then we have the 3 lights that are going to be tied together, and then the center is going to go and get connected as a star point across here and then tied all the way down to ground through what is a normally closed test button over here. Normally speaking, because all 3 of these lamps are going to be the exact same lamp, they're all going to receive an equal amount of current and therefore they're going to glow at the same amount of voltage. Really, if I take a look at them, if this is my delta system, if the delta system here were to go and be a 600 volt delta system over here, I would see that each of these would be receiving a phase value of 347 volts across them. So they'd be operating at 347 volts, but they do have to be rated all the way up to 600 volts because during a fault, they're going to go and see an increase in the voltage all the way up to that. Let's go and take a look at what actually happens inside of a fault, and it's laid out inside of point form below on your binders. What we see over here is that we have got a ground fault that is going to go and happen on my C line over here. So C line was fine, leaving from the transformer, coming through my service box, and then somewhere out there by my loads, I've got this thing ground faulted. If I don't have these lights on here, there would be no complete path for current flow, but the lights are actually going to go and complete that path for current flow, which we are now going to go and see through. I'll actually just change marker colors over here, which we are now going to go and see through here. It's going to go and flow through bond to ground, and because this is connected to the same ground over here, then that current is going to go and leave through this test button here once again. Once it hits this point, it's got the option to go into 3 different directions. It is not going to go through this path over here, because if I take a look at that path, we see that that path is going to go and lead back to the same point that it came from. There's no potential difference. It started out over here. It's not going to go back to there. Instead, that current is going to go and split up, and it's going to go through both of these over here. And it's going to go across through to here, and it's going to go across through to here. And if you take a look at it, because this point over here is the same electrically as this point over here, it's as if this light were being stretched right across in parallel from A to C. So it's going to see full line-to-line value of voltage. It was 347 volts that it had across it before. Now it's going to be burning way, way brighter because it's going to be seeing the full 600 volts. Same with this light over here. Both of these go all the way up. It's not going to be an unrestricted ground fault that we are going to go and see because we do still have these lights that are going to be in line. Although we do create a fault current, that fault current is always going to be controlled by the impedance of these 2 lights that we are going to go and see across here. What could happen, though, inside of these type of light installations is if you end up with a burnt-out lamp, that burnt-out lamp could give you false indication of a fault. And so that's the reason for this normally closed test button that we have down over here. If you go and press this normally closed test button, it is going to go and disconnect our star point from ground. So if I would open this up, we'll just go and draw this as being a big X inside of here. All of a sudden, this fault current path would no longer be able to make it all the way back from here, traveling, hitting this, and then traveling across over here. There's no complete path, and therefore, if there's no complete path, We are not going to go and have this unbalancing. Instead, all three of these lights being of equal impedance are going to go and self-balance our value of voltage around themselves. Which means that if I've got a fault on my system, and so I see that I've got my lights that are out, I'm just going to go and put this one here. I've got my A line lit, and I've got my B line lit over here. If these two are lit, and if I press this test button over here and the C line comes back on, that tells me that all three lamps are good to go. As soon as I release this test button once again, then the C line would go back out, which tells me for a fact that I know it is my C phase that is faulted out. You can go and at that point track the thing down utilizing your pulse tester or shutting the system off and tracking it out with an ohm meter. The other thing that you can do with these is instead of having lights, you can go and set up normally closed relays in parallel with the three lights over here. So what I can do is I'm just going to go and stick a relay coil across here, and that relay coil is going to go and have a set of normally closed contacts across. As long as it's energized, these contacts are going to be sitting open. We'll do the same with this one over here. Sitting open, set of contacts, sitting open. But then this one over here, that is right next to the lamp that is out, that set of normally closed contacts is going to go and close off again. And so you can monitor that through an alarm system. It would tell you, specifically which one you would have. What you would have to do is, once again, you would have to go and have a ranged type of device you would place across here. This thing would have to be able to go and operate all the way from, in this case, 347 to 600. So you couldn't use a 600 volt one necessarily if it doesn't hold in. You'd have to look for a specialized one. But there are these specialized types of relays. It's very common that you can pick up relays that'll run you all the way from 90 to 220 volts, the coils, etc. A lot of this stuff has really become a big thing through electronically controlled coils over the last couple of years. So makes it a lot more possible. Okay, that is it for ground fault detection off of a regular three-phase ungrounded system.